2a. So we're going to do limits involving infinity. So we're going to look at, as x goes out to either positive or negative infinity, what is our y value approaching? And a lot of times it's going to be approaching the horizontal asymptote for a lot of these graphs, okay? So let's talk about the horizontal asymptote. It says here, the line y equals b is a horizontal asymptote. The line y equals b is a horizontal asymptote if the limit as x goes to infinity of f of x is equal to b, or the limit as x goes to negative infinity of f of x equals b. Okay, so either way, you could go out towards infinity or out towards negative infinity. So I will show you an example, just a quick one, okay? If you have f of x is equal to 1 over x, okay? And if we took a look at the graph of this is your very basic parent function of a rational function. Rational functions look like this. They have 2 branches and 1 over here, okay? So what we want to do is we want to look at this as far as x is going out to infinity, or as far as x is going out to negative infinity, what is my y approaching? Well, think about if you were to plug numbers in. And let's say if we were supposed to plug 2 in, okay? We would get 1/2. Then we plug in 3 and we get 1/3. What if we plug in 1,000? We get 1 over 1,000. Is that a big number or a small number? Small. What if I go all the way out to infinity? How small is that number? So small that it's actually, as you go out to infinity, it's the asymptote y equals 0. Okay? And that would be the limit also. Pretty good, huh? All right, so we're going to do some tricky ones, though. They're not all going to be nice and fun. So let's try one. Number 1. Oh, do you know your asymptote rules? No. Okay, let's do this one on our calculator, and then we'll go over the asymptote rules. You don't have a calculator? The limit as x goes to infinity for 3x plus 1 over x minus 4. All right, so let's go ahead and find the limit here, okay? Now, as you're plugging infinity in for x, it's going in for the top and the bottom. So they kind of, you like to say, cancel out, right? In a way, they do. So let's go ahead and graph this. Make sure you put parentheses around it. 3x plus 1. Does anyone know the answer already without graphing? Like, what do you think it's going to be? 3. All right, we'll talk about that in just a minute, how some people know that. And then we'll divide by x minus 4. We'll hit zoom 6, and we'll graph it. Okay. All right, so as x is going out to infinity, so what I can do is I can hit trace, and I can jump on this graph and follow it out pretty far. I'm at 9, 10, x equals 10, y is at 4.5, 4.3, 4.2. Then it dips below 4. Okay, and it kind of take a while. Or you could go over to the table and follow it out there. 3.5, 3.4, 3.6. So it's actually, the limit is going to be 3, because that's what the horizontal asymptote is there. And if you know anything about these graphs, which we're going to talk about in just a minute, so it was 1, 2, 3. There was a vertical asymptote at 4 that we saw. We have a vertical, ew, what happened there? And we have a horizontal, and our graph went like that and like that. So actually either answer, if we're going out to infinity this way or negative infinity that way, our answer will be 3. As x goes out as far as it can, it is approaching 3. What did I do? Are you laughing at the asymptote? Are you laughing at my curvy asymptote?
Yeah.
If you draw it like this, then it's a thick asymptote. Yeah. to watch this video. It's PG-13. I'm sorry. Okay. Anyways. Okay, so let's talk about three ways to figure out a horizontal asymptote. Okay. It really depends on the degrees of the numerator and the denominator. So there are going to be 3 types. First of all, if you have a rational function, f of x equals, and we'll call it n of x for numerator over denominator, d of x. Okay? So if you have this, now there are 3 things that can happen. The degree of the numerator can be bigger, the degree of the denominator can be bigger, or they can be equal. Okay? So here we go. Number 1, if the degrees are equal, if the degree of n of x equals the degree of d of x, that's what the one was with the last one. They were both linear. The numerator was a degree 1, denominator is degree 1. What you do to find the horizontal asymptote is you just take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. So in that case, for that one, we had 3x, okay, over 1x. And so we're really just looking at this right here, ignoring the rest of it. And it's almost like you're doing that, and so the asymptote was 3, which is the limit. And think about it. If you're plugging infinity in for here and here, the infinities are going to reduce each other. Yeah, this is way out at infinity. Do you think this negative or positive 1 or negative 4 is going to matter way out at infinity? It doesn't. Not at all. Okay, the next one would be, number 2, if the degree of n of x is greater than the degree of d of x. So if the numerator is bigger, then actually it has no horizontal asymptote. There's no horizontal asymptote. And either your graph is going to either go to plus or minus infinity. Okay? So the limit will be plus or minus infinity. And that you would probably have to graph to check out. And then finally, the third one, if the degree of the numerator is less than the degree of the denominator, does anyone remember this one? And the horizontal asymptote would be y equals 0. And so will the limit. Bless you. Okay, so let's do a couple. Let's do some. Number 2, let's find the limit as x goes to infinity. Limit as x goes to infinity for 2x plus 3 over x squared minus 1. Okay? 2x plus 3, that's an x. I lost my stylus, so I'm using this one. It's not very good. 2x plus 3 over x squared minus 1. All right, what you really want to focus on as you're going out towards infinity is this 2x over x squared, okay? Which really just reduces to 2 over x. And as I plug in infinity, I'm getting 2 over a huge number. What is that going to? It's approaching 0, okay? Or you can remember your 3 rules. The degree of the numerator was 1. Degree of the denominator is 2. The denominator kind of wins, and it's y equals 0 is a horizontal asymptote there. All right, let me do a tricky one. Number 3. Let's take the limit as x goes to infinity for 5 plus x plus 1 over x minus 7. Okay. Now you do not need to get a common denominator and add them up and do all that. What you can do is use your properties that we learned last week that said if I have 2 functions, adding them together, I can find the limit of them individually. Okay. So what's the limit as x goes to infinity for a constant 5? What's the limit there? 5. We learned that. No matter where you're going, it's always just 5. Any x value will give you a limit of 5. And then this one would be, what's the limit of this one? 1. the degrees are equal, so it's leading coefficient, which is 1, over leading coefficient, which is 1, and so the total limit would be 6. Pretty good? All right, what else we got? Let me see. Now let's do some non-rational functions now, okay? So we're going to use graphs or tables to find the limit of these. Only a few more to go. Use graphs or tables to find these. All right, so we're going to find the limit as x goes to infinity for our function that we're given. We're also going to find the limit as x goes to negative infinity. I haven't done any of those. We can't forget those. And we're also going to find any horizontal asymptotes. That doesn't look like an H. Horizontal asymptotes. There you go. So we have 3 things that we're trying to find. Now, if I get an answer for this one or this one, it will automatically be an answer for that one. Okay? Because if I find the limit as I'm going out to infinity to be a number, it will be the horizontal asymptote. So let's go. Let's do it. Here we go. Number 4. Letter A. Let's go ahead and say that f of x is the sine of 1 over x. F of x equals the sine of 1 over x. So it says use graphs or tables. Okay, so you're going to want to graph this. Make sure you're in radian mode. And we're going to graph sine of 1 over x. Oops. Shoot. Don't you hate it when you do that? All right, zoom 6. And there's the graph. And that looks kind of weird, right? Now here's the thing about horizontal asymptotes. You're allowed to cross a horizontal asymptote, okay? You're not allowed to cross a vertical asymptote. But horizontal asymptotes are out towards infinity. It doesn't matter what's happening around this area. So for this one, it goes like this. It goes along here, and then it does this oscillating thing, and then it jumps up here. Hi. Oh, okay. Thanks. Thanks for stopping by. We really appreciate it. Having a good day? Good. Okay, so as we're going out to infinity, it says to use, or negative infinity, use tables or graphs. So I'm going to go to the table, and I can just keep following it out. Okay, and y is approaching 0. Or I could go to, do you know how to go back to table set if you go too far? You hit second window, and you can start your table at anything. I'll start my table at 0. At 0, there's an error, right? X can't be 0. It actually oscillates in there. And then this would be, it bumps underneath, but then it tapers back up to 0 again. And so the limit as x goes out to infinity, this way is 0. As I go out to negative infinity, it's also 0. And so my horizontal asymptote would be y equals 0. I got 2 more. Let's do the next one. You're going to graph these. So here we go. F of x, you might already know what this looks like. Maybe not. E to the negative x. Would you be able to picture that in your head? It's an exponential decay, right? Let's see. All right, but you can graph it. You'll get your calculator. So we'll go e to the negative x. And I graphed it. Yep, just an exponential decay problem with e as its base. Okay, and so it looks like this when you graph. It goes like this. Okay, and if you follow it, if you hit trace and you follow it out to infinity, y is never going to drop below 0. See how it says 2.398 e negative 5? That means 0.00002398, okay? So it didn't jump up to 2.38, that there's an e negative 5 there. All right, so as you're going out towards infinity, the limit as x goes to infinity for this function is 0. But is it necessarily 0 going the other way? No, what is it? It is. okay? You're thinking about your y values. As your x's are going this direction towards negative infinity, your y's are increasing without bound, going all the way up. And so the limit as x goes to negative infinity is going to be infinity. It goes up forever. But we still have a horizontal asymptote. Your horizontal asymptote is still y equals 0. It just affects as you're going out to infinity. It doesn't have to affect both. Did you see that word I wrote at the very beginning? It said or. It didn't say both. It says or. As you're going to infinity or as you're going to negative infinity. All right, one more. You ready for this one? It's a good one. And it's your last one, so that's always good. Let's do f of x equals x over the square root of x squared plus 1. So we need to find three things. The limit as x goes to infinity, the limit as x goes to negative infinity, and any horizontal asymptotes. Hey, when is your next quiz? Let me look. It's not tomorrow. No, don't let him tell you that. It's next Tuesday. So we're going to do 2-2 this week, 2-3. We'll review on Monday and take a quiz October 2nd. Crazy. And then there's only one lesson left to do in this chapter. It's very short. 2-1, 2, 3, and 4. All right, so let's do it. Graph it on your calculator. Have you graphed it already? Some of you have. Good. And some of you have not. No calculator? Where's your calculator? Oh, you got to get a new one. Well, are you going to take math in college? You'll probably need one. Not at this rate, he says. You'll probably have to then. All right, here we go. So take a look at this graph, and you're allowed to use tables or the graph, okay? So trace it. What is this getting closer and closer to? 0.99. What do you think? 1. Very good, Hayden. Very good. So what happens is it goes down here, and then it jumps up, and it goes like that. Almost looks like a cubic function, except, or cube root, except that it has asymptotes here and there. It's not going past those numbers. And so my answer as it goes out to infinity is what? We said 1. What about as x goes towards negative infinity? -1. And then my horizontal asymptotes, plural, y equals 1 and y equals -1. This has two horizontal asymptotes. I drew them in green. Well, I drew them in blue, but now I drew them in green. No, they are.